Our goal now is to take the process we went through in the last video and convert it into a formula that can be used so that we don't have to write out a sum of terms from a geometric sequence every time. Here's the idea. We're going to take a problem that looks just like the kind we had in the previous video, but we're going to use variables to represent the amount we deposit each month and the periodic interest rate and the number of payments. So the first payment we make at the end of the first month is going to earn interest n-1 times, right? It does not get to earn interest the first month because it wasn't sitting in the bank that month accruing interest. So the first payment earns interest n-1 times. If you know the periodic interest rate, like if it's 1% that month, you multiply by 1 plus the interest rate as a decimal. You do that for as many times as you apply interest. You multiply the payment by that, and this tells you how much money that initial payment will become at the end of all the payments, at the end of the period of time where you allow this first payment to accrue interest. So this is the total amount that the first payment grows into. So PMT is the amount of money you put in at the end of that first month, and this total is what that money will turn into at the end of this sequence of months. Then you'll make another payment the second month, and it's also going to grow because of compound interest, but it only grows from gaining interest n-2 times because it was made at the end of the second month. It missed 2 months where it would have been accruing interest if it had been made at the very beginning of this process. The second payment only accrues interest n-2 times. The third payment would only accrue interest n-3 times, and so on. The very last payment accrues interest 0 times because it's made at the very end of the last month and it never has a chance to earn interest. Okay, so this is a formula like we used in the previous video with actual numbers plugged in, but we can manipulate this to come up with a simpler formula. The first thing we'll do is factor out the number PMT, which appears in each term, pull that out front, and what's left behind are just these sequence of powers of 1 plus I. We have a geometric sequence here. 1 plus I to the 0, 1 plus I to the 1, 1 plus I to the 2, all the way up to 1 plus I to the n-1. When we have a sum of a geometric sequence, we can use our summation formula. We plug in 1 plus I for r. Remember, this exponent is equal to this exponent plus 1. So when we add 1, that's how we get just n here. Now we can simplify some more. In the denominator, if I distribute this minus sign, I get minus 1 minus I. And then 1 minus 1 cancels out, leaving just minus I. Now notice I don't have a minus sign here. That's because what I did was I changed the order of the numerator. Notice how instead of 1 minus a power of 1 plus I, this order is reversed. And so while this denominator would be equal to minus I, if I change the order of the numerator, I'm changing the numerator from a positive to a negative or from a negative to a positive, right? Because if 3 minus 7 is negative, changing the order, 7 minus 3 becomes positive. That's basically what I'm doing in the numerator here. So I'm changing the numerator from positive to negative or negative to positive, and that cancels with the minus sign that I should have in the denominator. So that leaves me with a simple formula to use for the future value of an increasing annuity. Let's apply it. You deposit $200 at the end of each month in an account that earns 3% annual interest. What will the balance be after 3 years? Well, we're applying $200 a month, so that's our payment size. The number of payments will be 36, 12 payments a year for 3 years. The periodic interest rate is the annual interest rate divided by 12, so that we can convert it into our monthly rate for compounding. So we take 3% written as a decimal, divide it by 12, and that's how we get the periodic rate of 0.0025. So we plug those into our future value formula. PMT goes here, N goes here, and the interest rate goes in the denominator, and this expression in the numerator, inside the exponent, is the quantity that's raised to the power 36 is 1 plus the periodic interest rate. So if you evaluate that on a calculator carefully, I would recommend putting parentheses around the numerator to avoid any mistakes, and if you do that right, you should get a final answer of approximately $7,524.11.